We are going to start week 3, day 3 of DHR HRD course. And today we have CAD CAM here, which is a well-established lab providing wide array of processing solutions since 1996. And it was one of the 3 labs in India to accommodate CAD CAM with Noble Biocare's Procera. And Mr. Rajkumar, who is the presenter today, he has taken several trainings in CAD CAM machines and software operations. And he has been to Germany, Italy, France, and many more countries for his experience in CAD CAM. So he has profound knowledge of CAD CAM and is the most apt person to demonstrate today signing of crown and tomorrow on the denture. So with this, I invite you, Mr. Rajkumar.
Hello.
Yeah, can we start?
Yeah.
Okay. Shall we begin now?
Yes, please. You may share.
My desktop is being shared.
So we can't see your desktop. You have to share. You have to click the green share screen icon on the bottom row.
Okay. So I start, madam, now?
Yeah, first share screen.
So just confirm if my screen is shared with others, everyone.
No, not now. You have to share screen. You have to click on the share screen option. It's in the bottom row, the button.
Okay.
Can you see the bottom row? In the center of the bottom row, there is a icon share screen.
Center. Don't find that icon.
What is in the bottom row?
Wait. Center of the bottom. Normal. Okay. Slide.
Where you stop video, priority, participant, then you see the chat. And then you see the screen.
Can I make a normal call to you?
Yes.
Yeah, just a moment. हेलो हाँ आवाज आ रही अच्छा आप जो मुझे गाइड कर रहे थे
आप अपना म्यूट कर लीजिए
I mute it just a moment.
हाँ तो म्यूट के बगल में वीडियो होगा है ना उसके उसको उसकी एरो को नहीं करना ना उसकी एरो को नहीं क्लिक करना हाँ शेयर स्क्रीन को क्लिक करिए जो उसके ग्रीन आइकन है नहीं आपने शेयर स्क्रीन क्लिक किया देखिए हाँ अब स्क्रीन शेयर हो रहा है अब हो रहा है थैंक यू
आप म्यूटेड हैं। अपने को अनम्यूट कीजिए।
Now it is unmuted.
हाँ,
So
ठीक है।
can
हाँ,
आ रही है आवाज?
आवाज
Okay.
आ रही है और आपका स्क्रीन भी डिस्प्ले है।
Okay, doctor. Okay. So maybe because of my voice was not audible, I'm speaking again. I wish all participants a very good morning, and let us begin our journey and exploration of dentistry, the lab aspect of dentistry, with the help of using CAD CAM dentistry. So what is CAD CAM? To just elaborate, this is abbreviated form of CAD and CAM. CAD is computer aided designing and CAM is computer aided machining or milling, whatever. Now, in the entire workflow process, what is involved is the clinic side first. This is the preparation, the routine standard preparation by in the dental chair by the dentist, and then the impression. This is a conventional technique of impression taking with rubber base, alginate.
Hello.
Yes, do you hear
Good
me?
morning.
Hello? Hello, doctor?
Please, everybody mute yourself, otherwise there will be disturbance. So I request all to mute yourself except the speaker.
So I continue, doctor?
Yes, please. लेकिन डिस्टरबेंस आ रही है कहीं से। आपके कमरे में दो सिस्टम तो नहीं होने?
नहीं, एक ही सिस्टम है।
कहीं से डिस्टरबेंस आ रही है, आई डोंट नो वेयर।
I'm in different room anyway.
चलिए, please start.
Okay, we continue irrespective of the disturbance. So I continue. This is the second step from the dental chair, taking an impression, which is normally the material used was alginate, rubber base. Then once the model arrives, the impression arrives, it is poured and we develop and prepare a cast model and we begin the process of the lab aspect, which is with the wax up, and the wax up is finished and then placed for the investment. The ring is prepared and then it goes for the casting. And after the casting, the finishing job, that step takes place. And after the end of the finishing, it goes back to the dental chair and it is luted with the cementation process. Now, depending on the processes, it could be S10 bond or it could be simply luted. Now, the conventional process, which we have been doing it for years, is the wax pattern and the casting is where the CAD CAM role, it plays now the role. The CAD comes in the wax stage and the CAM comes at the casting stage. So the preparation is done, of course, that is standard, no change until the robotics take over. And then scanning is done. Scanning can be by intraoral scanner or simply a cast is given and we scan with the extraoral scanner the lab side. Now, what are the unique features, benefits, and the reasons why the CAD CAM is luring this field also? Because CAD CAM exists in other industries also, and successfully it has transformed the life, and it is gradually transforming our lives as well. So the unique features is, to begin with, it's a time effective. It is much more accurate. Accuracy goes up to overall accuracy of 10 to 12 microns. The repeats are very minimal. because normally, as you might be aware, that when we have a full arch job or a metal fitting on the cast, sometimes inadvertently the model is little damaged slightly, and it doesn't fit in the mouth. Whereas in the CAD CAM workflow, the model is not affected. We don't disturb the model at all. We just scan the model and proceed to do all the jobs digitally. So the repeats are minimal. It is more reliable and consistent. Why consistent? Because like when we come in the morning, we are fresh, we do our wax up very nicely because we are charged up. But towards midday and end of the day, we are fatigued. So the consistency goes down, whereas the machine doesn't get fatigued. It works continuously round the clock, 24 hours, and the consistency is enough and continuous. It's a great comfort. The aesthetics are also very good because we can design aesthetics. Now here I would like to emphasize that some 2 years ago, software, CAD software launched by 3D Links, LYNX, developed by some Italian company. And I have seen it personally. It sort of creates a miracle of a smile, keeping the face. Uh, the advantage of this is that if there is a picture taken with the plate in the background, we can design the smile, keeping the smile lip line profile, the smile curvature, and the buccal corridor. So whatever the smile profile, we can create the smile and aesthetics. And we can also, based on that photograph information, we can prepare temporaries to be given to the patient immediately. So that is some unique feature of this particular aspect of this CAD 3D Links CAD designing software. And the whole process is digitalized. Now let us see the processes involved in CAD CAM. The first is scanning, then designing, and then milling. Now scanning with the intraoral, extraoral scanners. This is on the top left is a imetric scanner, which is supposed to be one of the best, most accurate scanner, and it is more scientific than any other scanners available in the market. It has a calibrated plate, so it adjusts and compensates for any variations in the data algorithm merging. So all data, it is not a picture, it is a data, and data is in form of a cloud of points. So those cloud points are merged together with the process called algorithm. So that algorithm processed data is much more superior quality with respect to the accuracy. And then there is another scanner. And then on the right side, you see the intraoral scanner available from various companies. The pros of this scanning system of intraoral is accuracy is very good. The time involved is less. Byte registration is very critical, and this is very interesting aspect of this intraoral scanning, because normally when we take aluvax or normal modeling wax guide byte registration, the patient glides the jaw according to his convenience. He doesn't care a damn what is your centric occlusion. So perhaps here a patient has a mouth closed as is the natural condition, and probably that is the best of centric occlusion. And then we put the scanner from outside on the buccal or labial side without disturbing the patient in the bite position, and record the bite in proper centric condition. Also other process like prosthodontics do for other aspects of biting also can be recorded very easily with intraoral scanners. Now this data can be emailed to the laboratory, and it saves transportation time and so many other hassles. It's very comfortable to the patient because with alginate, yes, gagging is much more. So also with the rubber base. So rubber base also causes discomfort to the patient. Some patients who are sensitive, they have a lot of reflex gagging effect. It's quite mess free. You dentist can appreciate that alginate and rubber base, they involve a lot of messy steps. So very easy for the dentist. And shade capture, yes, some 8 years ago, the easy shade was developed. This device could record the shade very comfortably, but somehow for some reasons, the longevity of the device was not good and it developed glitches. So probably it was discarded. Nowadays, these three shape intraoral scanners, they also tend to record shades, though not accurately, but broadly, yes, they give the scan data in a shaded form. So it helps the technicians to reconstruct the shades according to the patient's mouth shade. Now, cons is the initial investment is quite exorbitant at the moment. So it may not attract many people to invest so much of money. Extra-oral scanning, as I discussed about different brands available. There are many brands available in market. Now we enter into the CAD design. Now, CAD designing, the applications are inlays and onlays. Uh, there is something blocking. Okay, then coping, veneers, waxed up prosthetics. Now here technicians are very crazy and very whimsical about the shape and size they have in their mind. So many times there are limitations doing this shape size with CAD. So we can do easily, we scan the model first and then we do wax up of the whole job. We have that wax up ready before scanning step begins, and we place that wax up on the cast and record like a pre-op or wax up. There is an option available, you choose a wax up. So that wax up data can be merged with the model, and that can be contoured or designed, and then with that output we can go for using that as a milling uh, object. Anatomic crowns in zirconia, it is common things nowadays. That is also possible, same with emax, lithium silicates, lithium disilicates both. We can design full contour and mill it, and the outputs fittings are amazing, which are superior to conventional technique of pressing and then finishing and fitting. So if the incisal edges are sharp, maybe during fitting process we might damage, and then the fitting can be a slight issue in the mouth. It cannot be a natural adaptation in fitting when we do the conventional way of pressing the Emax lithium silicates. So with milling options, we can mill it to accuracy, and the fittings and margins. Margins at times, the pressed ceramic, it doesn't flow properly, the lithium silicates in the fin area of the margins. So there the integration and authenticity of margins are much better and superior, predictable superior with the milled pressed ceramic. Not pressed, I'm sorry, I'm mixing up. The milled options are much superior with respect to the margin integrity. Another option is ceramic facing. We can do a CAD designing with the labial or buccal side facing. There are space available to layer with the porcelain and then print the metal or mill the wax and cast it and then layer with the porcelain. Also, we can produce provisionals. Nowadays, it is very common in my dental lab that we mill in PMMA and deliver, which are outstanding aesthetics. Yes, of course, patients may run away because the life of this is almost 8 months to 1 year. So this is dangerous. Calling it a temporary and treating it as a temporary could be dangerous, because then in terms of money exchange or tendering the professional fee of the doctor can be hampered by this kind of provisionals. PFMs, bite splints. This is more interesting, customized abutments. In the conventional system, the stock abutments available from the company, they have a fixed heights of 1 mm, 2 mm, 3 mm, or at the most 4 mm collar heights. And the angulations also in limited angles, 15 degree, 25 degree. But when there are 6-7 implants, while during the CAD designing, we can achieve the perfect parallelism among the abutments that we design. That is the step one. The step two, the gingival contouring is again marvelous. We can follow the gingival line while designing the collars. So it is just exactly according to the gingiva. Suppose in case of a stock abutments, if a little submerged collar is there, is subgingival collar, and if excess cement is not removable, which flows during cementation process, that can be little dangerous. It can cause cementitis in the long process. And when we have had opportunity to discuss with Germans, they hate this aspect of excess cement flowing into the gingiva, which is not retrievable. So that's a cause of concern. Here, these customized abutments, they offer the wonderful privilege of having a quick enjoyable collar, and cement can be easily removed. So this is a beauty of customized abutments. A Malo bridge, I had this from downloaded from Google earlier, but nowadays these Malos are much superior. So I'll give you a picture later down the line. So you'll appreciate that today's Malos are much superior.
मुझे लगा और तुम्हें मैसेज भी डालना था.
May I request the participant to mute his speaker? Uh, and then it is a screw retained PFM with the open screw channel. Telescopic is another very fascinating. I did few cases recently, and that because with the conventional surveyor to achieve parallelism, we could miss out certain area when we are doing multiple telescopic copings, and maybe again when our enthusiasm level is down, again we can make errors. But here in CAD CAM, we have a perfect parallelism for telescopic retention, and it's just amazing. Hybrid denture is another very attractive part of whole thing, which I'll be including in my presentation part tomorrow. And the screw retained milled abutments with the milled connections in cobalt chrome, because ceramic bonds with cobalt chrome. CAD software. Now, what are the different, when we say modules, I often encounter with inquisitive people, inquisitive customers also, and many dentists. What are the modules? It is like the capability of a human being, the dental technician, to do that aspect of dentistry. When we say simple crown and bridge, it's a simple module. When we say implant, then the technician has the knowledge and understanding of dealing with the implant prosthetic jobs. Same with the full denture module. Now, full denture involves that module is there. So it begins with everything, CAD designing to the base, denture base, to the teeth designing, which can be milled. True smile, that is again to bring, to show the tooth in the lively position. Bars, just a moment. Bars, provisional modules, jaw motion import, virtual articulator. I'm just enumerating, reading out, nothing special. Model creator is of late very useful. It is really very useful in day to day. Maybe because I come across, I do this activity routinely, so I find it very interesting. So we just, when the email comes with the impression and the information of impressions, we just trim the cast digitally, take a printout, so the model is ready. Now that is useful, particularly when we are doing the work of PFM, ceramic layerings. Tooth library enables us to discover now, technician has knowledge of designing, but again knowledge has the limitations. Like he may know 10 types or 20 types. So in that 20 types, all patients have a different kind of tooth. So the tooth library enables to sculpt and construct tooth according to the real-time model, and DICOM viewer and partial framework, cast partial framework. Now we go with the CAD designing of a simple coping. We play this video. First is the order page. It's a live case of Dr. Kenal Shah, and we have taken the order. Now CAD is opening, and we choose the scan data available. We browse here from this yesterday's folder, 6th. We have, by the way, all the cases I have taken is just of yesterday. So I inserted the files in my PowerPoint, and here it is ready. We are going to show the live cases also. This is how we do the model. This is how we process the scan data. This scanner used intraoral was I500 from Medit. So every intraoral scanner produces different kind of scan data. Somehow I find this three shapes scan data easy and smooth to handle. So this is a typical case of upper right 5. And we can go a little faster. We trimmed it, we adjust and prepare for. Now this is something which we encounter the problems. I'm sharing the problems. It can be noted of, and during the intraoral scanning, this process can be taken care of. Like you see, there is some defect in the scanning, so I'm just correcting it manually, the scan data, and this is the same way where there is some nodule present in the model. We either take out or scoop out and they score the cast. So something similar, but maybe this aspect can be improved through proper learning. When we are using a device of intraoral scanner, we should be able to capture the data much more better. You can see on the premolar, first premolar, the distal side there is excess which could have been avoided if the whole data is merged with the algorithm process I said earlier. So we should keep in mind, we have to understand the mechanism of working of the intraoral scanner so we can avoid such mistakes. It is something like impression material doesn't flow and there is excess in the plaster. So this could happen with a digital form also, but it's okay. I mean, we are on the learning curve. Now it is processing which takes time. It's all real time. So I'm attempting to show that how quickly we can design the CAD. If it is in the dental chair side or dental office side, it could be constructed much more quickly. So you can see the whole thing lasts from model designing to everything in less than 10 minutes. We could go a little faster. This is a model ready, the die detached. We cut the excess. We cut excess here also, and ready the support pins attached to hold the partial arch cast for the build up of porcelain, and this is done. Now we go for mirroring and copying of image, which is also a live case I did yesterday. The copying was just milled, maybe that milling noise was humming sound of milling was there. That is stopped. So we'll show end of the presentation the mirrored prosthetics of a live case. So we just begin quickly and run through this. This is order taking. I think it is known to most of the participants, so no need for us to dwell on this. We choose the options of processes and the material we choose, and then milling or printing option. Then we open the CAD design. Now this is a model we have imported, uh, scanned with the extraoral scanning, and here we do the margins. Now I attempt to place margins in the sulcus area closer to the tooth stump. The reason being we want to avoid impinging of the gums. So I think close to the evening I got the cast and I thought let us, it could be interesting. So I inserted the slide. We're just doing a real time, which is approximately 8 minutes for the whole CAD designing. So if it is CAD is there in a CAD CAM in dental chair side, you can deliver the temporaries instantly, maybe in half an hour, less than half an hour, including milling time.
क्या चल रहा है अभी तक? पहले तो मॉड्यूल क्रिएटिंग दिखा है, फिर उसके बाद अभी डिजाइन दिखा, अभी फिलहाल डिजाइन दिखा रहे हैं।
Now, until now, it may appear very simple things, but what can be amazing and very exciting when it comes to the CAD designing after the margins are marked and the insertion path is determined. We have a joint insertion path because it's a joint crown.
इंग्लिश थोड़ा ग्रेड कुछ अच्छा बताया, जितना हम लोग जो यूज करते हैं वही है। कौन कर रहा है? आवाज क्या है? राजकुमार सर बोल रहे हैं, कोई और करता है।
Now here comes the mirroring, and that is very interesting. This is a path of insertion determination that there should be usually one path of insertion.
ये पता नहीं, लाइट तो चल रहा है, मुझे भी पहले ही दिखा रहा था।
तो मतलब फुटबॉल कर ली। हाँ लगा कहाँ से
ऑडियो से बंद करेगा।
बाबू ना क्वार्टर डालो कोई को निकालो सही।
Now here is the mirroring of the tooth, which is a critical part. So we just apply the tooth which we want to copy. And
स्केल चेक कर, माउंट किया हुआ है, फोटो खींच के रख। जैसे काम मत कर, यहाँ पे दिखने के बाद भी वैसे करेगा।
Now this is how the mirroring is done. So we will do some smoothing of the cervical area, and this is just a replica, keeping in mind the symmetry of the teeth, the contralateral symmetry. And we correct this deficiency of the tooth, which is comes through impression. Add some material here, smoothen it. Now this is complete. You can see the timing. This is a real-time workflow, and this job is complete in about 8 minutes or 2 minutes. And we save the data. Then crown and bridge live demo, which is again we'll rush through it very quickly. This is true smile designing, so that can be a really very interesting thing. We choose the file where the scan data is loaded. Now this is a cast. We mark the margins as usual. Mark the margin on the distal. This is the insertion path determination. Mirroring not required because these 4 teeth are not worth mirroring. So we take a tooth library, choose from the library in the CAD. Then we place it
देख दोनों देख सकता हूँ पहले वाले खोले
Adjust the contacts. Adjust for the buckle corridor. It should not be bulky, so that it aesthetically and functionally both it is acceptable. So we correct the occlusion. Now this is occlusion we have adjusted by cutting the intersection. You can see this process, and
सुनो इनका मोबाइल नंबर टाइप करके इनका मोबाइल नंबर टाइप करके मोबाइल नंबर हाँ मोबाइल नंबर इनका भी यहाँ पे नीचे मोबाइल नंबर लिखो दोनों का सब टाइप
we have
करके
cut the intersection.
दोनों का डाल तब निकालो फिर
Dr. Divya, my humble request, if you can unmute from your end, your colleagues, speakers, I'll be thankful.
Yes, please.
Yeah, thank you. Now we have about to finish this restoration crown and bridge live demo in roughly, you can see the timings, you can appreciate in approximately 7.5 minutes, the job is done.
इसका
Then we want to do further trimming of the pontics, and here it is complete. So this job is complete, and the crown and bridge live demo in 7.5 minutes. And then we have milled in zirconia. The output I will share with you at the end of the session. Then the Malo bridge.
935 902322.
This is a cast of implant supported Malo bridge, a regular dentium multi-unit. Just occlusal view to appreciate how many implants. Thankfully, the angles are within control, within limits, not much of divergent implants. Then we take, we designed, of course, it was some few days ago, we designed the Malo bridge, implant supported screw retained Malo.
Mr. Rajkumar, are you going to show one scenario, means just design something and show to our, not the pre-design, if you can just go and
Okay, you want a live demo because I'm sitting in a secluded area. In my hurly-burly of activity, that CAD area is a little different. So if you suggest, I can do it tomorrow, the live
yes, we
designing.
wanted a live demo.
But what I showed, the 3-unit bridge and the copy and the mirroring, that was live. I did
Yes,
yesterday evening.
yes,
I just recorded.
yes.
So it could be the same. I mean, that was a perfect real time, doctor.
Okay.
A perfect real time. But still, if you suggest, we'll do it tomorrow.
Yeah, we
Then
wanted
we
to see,
place.
yeah, how much. So just live, do it straight away. Then they know that this is the way we have to choose this option. We have to choose this option, because when you record it and show, then it is very fast. For the first time person, it becomes difficult.
Okay, I was just a little hastening the process, but okay, I can do it tomorrow. Sure.
Yes, please. Yes, please.
Because then I'll have to connect through my scanner computer.
Yes, yes, yes.
Okay, doctor. And then this is what we milled, the bars, 2 different bars, which look similar. Amazing. And we did the milling. I have on my left side. This is finishing the milling. And same bar, we Malo bar, we took it out This is a machine in my office. On my left, I'm sitting in another CAD CAM room where I can show this machine. Now was this is the output of bar, milled bar, and how to process it. Like the gingival part, we can put a composite, and either we put teeth or we can put lithium silicate, lithium disilicate copings, crowns, or maybe zirconia crowns, according to the choice of material recommended by the dentist. And we go back to this. This is a device, a milling device, which mills with accuracy of less than 1 micron. It's the highest in industry. And these are the outputs achieved. Uh, Somehow I don't have this device ready. I am expecting it by mid 21, somewhere in June, July. I would be having this device is used by companies like Nobel Biocare, Straumann, Dental Direct to mill their implants. So this we can have a customized abutments, which you can see the multi-unit abutments. And this is my in-office, which I installed now. It is a lot of coincidences, but I installed this machine yesterday. Completion of installation was done. I took some output, printed output. So this is a new age technology of DMLS, direct metal laser sintering. So this is a process which enables us to have a integrity of margins, accuracy of margin very high. And this is our in-house device. This is how the we place the object, generate the slice path on computer. Sysma is the name of the machine, which is supposed to be best in the world. Now in India, only 2 people have. I am one, and prior to me, Dentcare owns it. It's a very expensive device, which prints to the accuracy of 20 micron. So this is how the metal printing, the copings of PFM base is achieved. And this is a picture which I have showed you already. I thank you so much for paying attention to this part of presentation.
Thank you so much, Mr. Rajkumar.
Thank you, madam. Thank you so much.
Any questions?
Is there anything, any curiosity? Yes.
Hello.
Hello.
Hello, Mr. Rajkumar. This is Dr. Swati.
Yes, doctor.
I have one question.
Yes.
The case which you showed was scanned through the cast, and then you
Yes.
designed the prosthesis.
Yes.
Many a times the doctors with intraoral scanner would be sending the scanned image right from the patient's mouth to your lab.
Yes.
So in both the scenarios, which is the most commonest complaint you have heard from your dentist? One where the image has been scanned from the cast, what is the most common complaint? And one when the image has been scanned from the mouth and sent to you for designing. So once you mill the crown and deliver it, so what's the commonest complaint that you see in both the situation?
I mentioned you, doctor, earlier that like it was the margins were not captured accurately. It's something similar to flowing of impression material. So if data is when you are recording the impression, you see also simultaneously live on the computer.
Yes.
So you should appreciate, be little cautious. See, the devices are there to aid you, but your personal skill makes you perfect. So end of the day, it is your personal skill which matters in all the respect. Like same material, same rubber base, why somebody takes extremely good impression, why the other person is not capable of producing the same accuracy of impression. So that is one complaint I would say, which is unique, a common complaint existing for ages. That is one. Second is, while recording the JR, many times the upper and lower jaw are not merged with the recorded jaw relation. So it so happens that I have to manually adjust in the CAD the upper and lower cast, assuming my going through my intuition. Yes, this is what could be the likely, because we have gone through in the whole working life that this is how the occlusion should be. So if there is some weird occlusion, the job is not taken in the centric, is not recorded in the centric, then we have to manually do it. So that is another complaint which is very common. Third is many times, like it's again similar to what we do in the routine practice, like impression material is not flown into the critical margin area. So even when you do a two-step or one-step, whatever, but the putty and this light body has to flow very accurately into the marginal crevices. And if it does not, then impression is not accurate. The same problem happens that some scanning area is missed out. So that is also a complaint. Now I have already scanned data from my, I think I just saw in the morning today, and just a moment, inbox. I have this new case of it is arrived just maybe hours ago. So I have to go through it. I have to work on the impression data. So these are the complaints, but okay, I don't make it as a complaint. It's my normal and my normal life in dental as a dental technician, madam.
Thank you.
That was very good to know from your perspective. Ma'am, my question is still there. Can I go ahead or
Yeah,
we'll
yeah,
ask
sure,
it?
sure. Please go ahead.
What is the complaint which the dentist gives to you or complaints once you send them the milled crown? Do they have difficulty in placing the crown with intraoral scanner, or when it is done with a lab scanner more, or the contacts are tighter? What is the difference between the two scans when the patient, when the crown is delivered to the dentist? What does a dentist feedback, what is the feedback of the dentist to
I
you?
think Swati,
Yeah,
you
yeah,
should.
I understand your point. I do understand your question. The dentist, like, see, the life has definitely become easier compared to conventional method of impression taking. It has become a lot easier. The ease is with respect to accuracy. As I mentioned in the very beginning of the presentation, the predictability of fitting is very good. So that is one headache which is gone from the dentist mind. We can assume that it will fit accurately. The problem, yes, sometimes we print the models. So if you see on my background, if I switch off my video, the presentation video, you see on my background, there is an object Eden 260, which prints with 16 micron. It's a very expensive printing device, resin printer. So when we print the models, it has to be accurate. If model printing is not accurate, and we fit according to the printed model, which adds to the error given by the dentist scan data, that can be a cause of concern. And that is the area where we need to really work on the dental side, the lab side. So all lab people should be careful not to add to the error of fittings by printing an model which is not so accurate. It should be printed with less than 20 micron accuracy. Then only the fitting can be guaranteed, not otherwise.
Swati, I
I
was
hope I have
thinking.
answered your question, doctor.
Yes, ma'am.
I was thinking you
Hello,
should
ma'am.
take up this project to compare
Yes, ma'am.
scans from
Yes, ma'am.
intraoral scanning and the models, and then get the processes done and
Ma'am,
see.
I'll talk to you about it, ma'am. Yes, ma'am.
Okay, okay.
Your questions are welcome. Yeah, yeah. But yes, Dr. Divya will decide what is the appropriate time, what is the length of answering and discussions. Of course, you're the best judge.
Thank you, Mr. Rajkumar.
Thank you so much.
Any other questions for him? I was thinking, Mr. Rajkumar, if you take up this case which you have received today, and from the very beginning, if you can take this up in front of us and let us see what are the changes are required when a case comes to you, how do you prepare your file, how do you take it up. So the entire process, if you can do in front of us, that would be a good experience.
I think, see, it is my professional skill, and to share it can also be a little chargeable kind of thing, madam, I'm afraid. But yes, I would be very keen and happy to present tomorrow one case, but to discuss in detail could not be in domain of presentation. it could be more in domain of a day's length. In 1 hour length, it's quite difficult to encompass the nitty-gritties of what needs to be done, and what precaution needs to be taken from dentist and from lab both. So it could be a little longer length of discussion, doctor.
Okay, okay, okay. So thank you so much, and may I take this opportunity to present you with a certificate for today.
Thank you,
I
doctor.
would like to
And tomorrow, of course, I'm sorry to interrupt.
yeah.
I'm sorry to interrupt. Tomorrow again, we'll do some live lining, designing of everything, and maybe the same case what we did yesterday. Or if I find a model, new model, another model, I'll do a live demonstration tomorrow if possible. But I'm worried that the digital denture part, some critical areas I may miss out. So that could be my concern.
Okay.
But you suggest, and I'll modify accordingly.
No, I think the topic for tomorrow is very crucial. So we would like to give it full detail. Apart from that, if you want to include some more from today's part to incorporate more videos, it would be fine.
Yeah, sure. And I thank you, Dr.
Not
Swati,
that
for
we
asking
want
questions.
only 1 hour. It could exceed also if you feel like we may exceed to have a live presentation.
Yeah, if you give me freedom that like I have
Yes,
to,
yes, you are free to speak. So for how much time you want to speak?
sure, doctor. I thank you for giving me that opportunity.
Okay. Thank you so much.
Thank you, doctor. Thank you so much. And thank you all participants.
Thank you.
Bye. Bye.
Thank you, sir.